All right, well, here's a few news stories. This one here from the Register I thought was very interesting. The headline pretty much tells you it all. They interviewed people in the UK, and 40% of them said if they had a data breach, they would be told by management not to report it, even though that would be a violation of the law, because the belief was that the embarrassment and cost to the company, presumably, would be more harmful than the fine. And in America, that number is 70%. So we had a spirited discussion about this on Paul's Security podcast, and they said they're not really surprised this is the case. Your chance of getting caught is not high, and the fine is not that high, and the cost impact on your stock price is higher. So it's probably an understandable business decision for a lot of companies to not report their breaches. As an end user, one thing to consider is that probably a lot more of the companies you use have been hacked than the ones you hear about in the news. If it's 70% that don't report them in America, that means every one you see, there's like 3 more that didn't report it. So one conclusion is you really should use a password manager. So use a different password at every site, because a lot of the sites you're doing business with probably get hacked and leak out your password. And you don't want that same password to let them in other systems. So I have a lot of articles about AI, and we had a period of discussion about this. This one I thought was interesting. Now, the person, Sasha Lucioni, she wants to say that AI is using up too much power and too many computing resources, and I wasn't impressed by that. But I was very interested in this one graph she had. This shows the power of AI systems, and I'm going to demonstrate the AI hands-on projects later on today, because so this graph shows, you may know Moore's Law is what's controlled the computing revolution. And in Moore's Law, computers get twice as fast every 18 months. And it's been that way for like 40 years. And that has led to the modern world with the computer revolution, to where everybody feels pressure to become computer literate. But with AI, it is much, much faster. This is the number of parameters, which is a measure of how smart your AI is, and it rises by a factor of 10 every year. So it is much, much faster than the computer revolution. So what this means is, imagine if you tried to get a job in 2010 and you didn't know anything about the internet. You would be totally behind, like somebody that couldn't read. It'd be ridiculous to try to even participate in the modern economy in any way without understanding the internet. And AI is coming up much, much faster. So probably within a year, unfamiliarity with AI is going to be a really serious flaw. So that's why I'm going to repeat the demonstration of these hands-on projects later and try to get all of you to start using AI programming and seeing how it works now, because this rate of increase means that it's going to become ubiquitous. It's going to have a huge effect on every job market very soon. And you want to be aware of it. You want to have experience programming it. You want to understand how it works. Good evening, folks. All right, so, and then things are coming up. For example, Beijing. The Chinese government has declared what they're going to have rules for what their AIs can do. And the problem is, as you're going to see, it is very difficult for an AI to be forced to obey a rule. You do not write a program like you do in other languages where you give it a rule and it has to obey that rule. Instead, you just train it like you might train a child or a pet, and it may or may not obey your training. So it will be very difficult to say. They want to make sure that whatever it does, it will reflect the core values of socialism and must not contain subversion or overthrow of the system or incitement to split the country. And it is not simple to enforce rules like that, although the United States government is also considering what rules to put on AI. And you would like to say it's going to have rules like it can't spread disinformation or help people commit crimes or something. And we're going to see to what extent the developers of AI are able to enforce any rules like that. It's understandable that government agencies want to have rules like that, and businesses have to have success like that, or they can get sued if people take harm from their AI development products. But in the current type of AI is being developed, there are not good ways to enforce rules like that, as far as I can tell. But they are going to need to figure out some way to do it. So Elon Musk signed a letter a couple of weeks ago saying that everybody should pause development on AI for 6 months while we have time to develop the ethical rules. And one person on Paul Security Weekly last week said, he's just trying to tell other people to stop so he can race ahead. And that seems to be true. He's purchased 10,000 GPUs for a generative AI project at Twitter. So he's talking out of both sides of his mouth, which is very common for Elon Musk. When he says something, it's often to distract you while he picks your pocket with the other hand. So obviously, even though he signed that pause letter, he knows that no one's going to do it, and he's continuing to rocket ahead, which I think as a business decision, everybody has to rocket ahead with AI. It is going so fast, it is so important that if you don't develop it fast, other people will just take over and you'll be left behind. Any kind of pretending that there's going to be a pause is just ridiculous. There's no chance of a pause right now. It's a rocket moving forward. There are a couple of interesting articles about mitigations for exploit development. Are all those GPUs to store and access data quickly? Yes, that's right, to do the processing. AI is going to have billions of parameters, and GPUs are what you need to handle that many calculations fast. Just the same reason you need that many to crack passwords. So there's two academic articles that are pretty interesting, and they're very much like what the lecture today is going to be on as we talk about mitigations against exploits. So this one here talks about backward edge protection. Backward edge control flow hijacking is the fancy technical term for a normal buffer overflow attack of the kind we've been doing, where you overflow a string, you have a stack, and the stack has a string variable, and it also has pointers on the same stack. So if you overflow the string, you can change the pointers, which are used to return from a function, which is called backward edge control flow. So to prevent this, there are mitigations we've talked about, like stack canaries. Stack canaries are a special value placed on the stack that separates the control flow pointers from the stored arrays, the strings. So if you overflow a string and try to get down to the area where the pointers are stored, it detects that and stops it. And shadow stacks, which we haven't talked about, are another defense where you take all the pointers and put them on a second stack. All the variables are on one stack, but the pointers are on a second stack, so no overflow of the variable can reach the pointers, which amounts to the same thing. So these mitigations would pretty much end the kind of buffer overflow attacks we've been doing. However, there are ways to get around it, and the obvious way, which we've been using in class, is to exploit the exception handler. Now on Windows, this is well known. You exploit the structured exception handler. Now you corrupt a variable so some kind of exception happens, and then you modify the exception handler, and then you get control of the machine. So this has been well known, and we've done it in the projects and lectures and everything for Windows, but apparently it was not developed for Linux or Unix. And the point of this paper is he developed a Linux version of this, and he calls this catch handler oriented programming, or CHOP, and found that there's a ton of Linux software that's vulnerable. They found hundreds of vulnerable spots in Firefox and 7-Zip and other popular programs, and they found it, had a chart someplace of how many they found. So anyway, I might be mixing that part up. Anyway, he found a lot of vulnerable functions, so it really just extends structured exception handler exploits to Linux, and apparently there's a whole lot of vulnerable software there, so that's a thing to know about. And this one here is a second academic article, Warp Attack. This is going to bypass control flow integrity. And now the point of this is actually referring to the very first attack that we did in this class, which I remember I mentioned at the time. This was a very weak sounding kind of attack, but it's the hardest to stop, which is code reuse, where you gain control of the instruction pointer and you change it to some other function that the developer put there. You do not add any additional code. You just run code in a different order than the developer expected it to run. That's code reuse. And they're dangerous. You can take over the box with them. And so the mitigations are address-based layout randomization, data execution prevention, and control flow integrity. Now, control flow integrity checks to make sure that you can only enter functions at the official entry point, and you can only jump to the official places you should go. And we talked about this for some of the heap guards. One of these defenses is control flow integrity. However, it turns out that control flow integrity defenses can be overcome by your compiler. Compilers compile code and then they optimize the code to make it run faster. And it turns out when they optimize it, they put back in some of the vulnerabilities that the CFI was trying to prevent. And in particular, they tend to create time of check to time of use attacks, vulnerabilities, where they save something somewhere, and then they come back later to read it without realizing that some other process could have changed it. So you now have a race condition where you can change a number, and they're saving something like a pointer somewhere, and you can change it and then take control of the box. And they developed a general way to attack this. They call it the warp attack. And again, they found that a lot of packages are vulnerable. I think this is the one where they attacked the 6 popular packages. Let me see if I can find that chart. If it's the one I'm thinking, there's a chart at the end of the, yep, this is it. Let me zoom into this bit. All right, so here's what they did. They only went through these 6 products: Chrome, Firefox, Apache, Java Virtual Machine, 7-zip, and Text Studio, whatever that is, and they tried it on these operating systems: Fedora, Debian, Ubuntu, Windows, and Mac. And they found a bunch of vulnerable points on every one of them. More on Fedora than the others, but Linux and Mac are included too. These are all double fetch gadgets in these packages where it fetches something twice, and therefore potentially this attack would work. So it seems like it's a defect in the compilers, and this reminds me of the predictive vulnerabilities called Spectre and Meltdown. Your processors were made faster by looking ahead and beginning to execute commands beyond the current command, which would make them faster, but that led to a vulnerability. This is a fairly common situation where an attempt to make the computing faster opens up a vulnerability. So, of course, one way to prevent this would be to not optimize your code, but nobody would like to make your Chrome or Firefox slower. So probably they just need to improve the compilers to be more smart about how they optimize or something. Anyway, and they checked all the compilers and found that basically every compiler has this flaw. GCC, the Microsoft compiler, and Microsoft VC, CLang, G++. So basically all the compilers make these mistakes, and all the operating systems and all the software packages are vulnerable to it. So it seems like an important finding. All right, and that's enough. That's all the time for this. Let me stop this.